Hi everyone, this is Nagama Ramakrishnan and I am very happy to join you all again. So today we are going to see about polynomials. So what are polynomials? Let x be a variable and n be a positive integer and an minus 1, an minus 2 all will be constants. Then f of x is equal to an x power n plus an minus 1 x power n minus 1 plus etc. plus a1 x plus a naught. This is called the polynomial in variable x, where n is a positive integer and an minus 1, an minus 2 all are constants. They are real numbers and they are called the coefficients in this polynomial. And an x power n, an minus 1 x power n minus 1, etc. all are the terms of the polynomial. And here we have seen now what is a polynomial. So this expression is called the polynomial. So next comes the question. This is like a algebraic expression. So now we can ask a question. Are all the algebraic expression of polynomials? No, it is not. So there is a condition for it. So let's see what is it. So in an algebraic expression, all the exponent must be non-negative integer in order. So all the exponents in the algebraic expression should be non-negative, that is positive only, or it can be 0 and it should be in order. So let's see an example so that it will be clear with it. So p of x is equal to 3x minus 2 and q of y is equal to 3y square minus 2y plus 4. And the third one is f of u is equal to 1 by 2 u cube minus 3u square plus 2u minus 4. So these are the examples of a polynomial. So let's check with the condition. So what is it? Here the exponent is 1, that is positive, and here that is also a positive. Here 2, 1 and here also positive. So these are algebraic expression and that are examples of a polynomial. And next we are going to see the degree of the polynomial. So how to find the degree of the polynomial? So it is the highest power of x, or we can say it as largest exponent in polynomial. So both are the same. So we can check with the example here, which is the highest power of x, that is 1. So in this polynomial, 1 is the degree of the polynomial. In the second example, here 2 is the highest one. So the power of 2, that is the highest, and 2 will be the degree of the polynomial. In the third one, 3 is the degree of the polynomial. So we have seen now what is a polynomial and few examples and how an algebraic expression will be a polynomial and the degree of the polynomial. The degree of the polynomial is that the highest power of x, the largest exponent in the polynomial. So now comes the types of the polynomial. Here we have some types that are, if the degree of the polynomial is 1, we call it as linear polynomial. And if the degree of the polynomial is 2, we call it as quadratic polynomial. And if the degree of the polynomial is 3, we call it as cubic polynomial. And if the degree of the polynomial is 4, we call it as biquadratic polynomial. So when the degree varies, so we call the polynomial also in different names. So linear polynomial if the degree is 1, and quadratic polynomial if the degree of the polynomial is 2, and cubic polynomial if the degree of the polynomial is 3. So I think you all are clear with these things. Next we can see how to find the value of a polynomial and zero of a polynomial in the. So now we are going to find the value of a polynomial. So let's see how it is. So value of a polynomial f of alpha. So how we can find the value of f of x at x equal to alpha. X is equal to alpha, where alpha is a real number. So when we replace the value of x by alpha, we are getting it as f of alpha. So by replacing the value of x is equal to alpha, we are getting the value of the polynomial. So let's see by the example. So the value of we have to find the value of the quadratic polynomial f of x, that is equal to 2x square minus 3x minus 2 at x is equal to 1 and x is equal to minus 2. In these 2 points, we have to find the value of the polynomial. So how you will get these values? We have to substitute the values in this equation, that is in this polynomial. So while replacing the value of x as 1, we get it as f of 1 is equal to 2 into 1 square minus 3 into 1 minus 2. So by solving this, we get the answer as minus 3. And the next value they have given is x is equal to minus 2. So here by replacing the value by minus 2, we are getting it as f of minus 2 is equal to 2 into minus 2 the square minus 3 into minus 2 is equals 12. So by solving this, we will get it as 12. So nothing but this is nothing but very simple thing. By replacing the value of x by the given numbers, we are getting the value of the polynomial. So next we can see the zero of a polynomial. So what is the zero of the polynomial? A real number alpha is the zero of a polynomial f of x if f of alpha is equal to 0. So when we substitute some value, some real numbers, we are getting the value of a polynomial is 0. So that is said to be the zero of a polynomial. So for a linear polynomial, we can see f of x is equal to ax plus b, where a is not equal to 0, has only one 0, which is given by this formula alpha is equal to minus b by a, that is minus of constant term divided by the coefficient of x. So the coefficient of x is a and the constant term is b. So the zero of a polynomial, that is zero of a linear polynomial f of x is equal to ax plus b is given by alpha is equal to minus b by a, that is minus constant term by the coefficient of x. So I think you are clear with the value of a polynomial and zero of a polynomial. And today we have seen what is a polynomial and few examples of a polynomial, then degrees of the polynomial, then next few types of polynomial, then value of a polynomial and zeros of a polynomial. And in the next classes we can see few examples, few problems in the polynomials. So we can be clear with what is a polynomial is and how it is useful for us. Thank you. Thank you for watching these videos and thank you for supporting me. Thank you.